Welcome back to Java Internals Crashcasts. I'm Sheila, and with me as always is Victor. Today we're diving into a fascinating topic in our advanced topics season, memory barriers and reordering. This is the final section of our Java memory model chapter, so get ready for some mind-bending concepts.
That's right, Sheila. We've covered happens before relationships, which define when one event in a program is guaranteed to be visible to another, and the volatile keyword in our previous episodes. Now we're going to tie it all together with memory barriers and reordering. This topic is crucial for understanding how Java ensures correct behavior in concurrent programs.
Before we jump in, let's start with a quiz for our listeners. Here's the question. In a multi-threaded environment, can the Java runtime or the underlying hardware change the order of memory operations in a single thread? Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a tricky one, Sheila. It touches on the core of what we'll be discussing today. I'm sure our listeners will have some interesting thoughts on this. Let's break it down a bit without giving away the answer. We're essentially asking about the predictability of operation order in a concurrent context. It's a fundamental question that affects how we write and reason about multi-threaded code.
Exactly, Victor. Now, before we dive deeper, could you explain what we mean by memory operations in this context?
Certainly. Memory operations refer to reads and writes to variables in our program. This includes both primitive types, like integers or booleans, and object references. When we talk about memory operations, we're concerned with when these reads and writes become visible to other threads. It's like passing notes in a classroom. We want to know when the note is written and when others can read it.
Got it. So, let's start with the basics. What exactly is instruction reordering and why does it happen?
Great question. Instruction reordering is an optimization technique used by both modern CPUs and Java runtime to improve performance. It involves changing the order of instructions to execute them more efficiently, as long as the final result remains the same from the perspective of a single thread.
That's interesting. So it's like rearranging tasks to get things done faster, as long as the end result is the same. But how does this impact multi-threaded programs?
Exactly. Your analogy is spot on. In multi-threaded programs, this reordering can lead to unexpected behaviors because different threads might see operations occurring in different orders. This is where memory barriers come in.
Memory barriers? That sounds important. Can you explain what they are and how they relate to reordering?
Certainly. Memory barriers, also known as memory fences, are instructions that enforce ordering constraints on memory operations. Think of them as traffic lights for memory accesses. They ensure that certain memory operations are visible to other threads in a specific order.
Oh, I see. So, if reordering is like cars moving freely on the road, memory barriers are like traffic lights ensuring orderly movement. Are there different types of memory barriers?
Great analogy, Sheila. Yes, there are typically 4 types of memory barriers: load-load, load-store, store-load, and store-store. Each type prevents different kinds of reordering. For instance, a store-load barrier ensures that all stores before the barrier are visible to other processors before any loads after the barrier.
That's fascinating. How does Java implement these memory barriers? Do developers need to explicitly use them?
In Java, memory barriers are typically implicit. The Java memory model specifies where these barriers are required, and the JVM inserts them automatically. For example, the volatile keyword we discussed earlier implicitly introduces memory barriers to ensure visibility and ordering.
Ah, so that's how volatile ties into this. It's all coming together now. But I'm curious, what are the performance implications of using memory barriers?
Good question. Memory barriers can have a performance cost because they restrict the optimizations that the CPU and JVM can perform. However, they're crucial for correctness in concurrent programs. It's a classic trade-off between performance and predictability.
I see. So, developers need to be aware of this trade-off when writing concurrent code. Are there any common pitfalls or misunderstandings about memory barriers and reordering that our listeners should be aware of?
Absolutely. One common misunderstanding is assuming that all operations in a synchronized block are automatically ordered with respect to other threads. While synchronization does provide memory barriers, it's important to understand their exact semantics. Another pitfall is relying on implicit ordering in non-volatile variables, which can lead to subtle bugs.
Those are great points, Victor. It sounds like understanding these concepts is crucial for writing correct concurrent code. Do you have any tips or best practices for our listeners?
Certainly. Here are a few key points to remember. 1. Use high-level concurrency utilities when possible, as they handle memory barriers for you. 2. When using low-level constructs, understand the guarantees provided by volatile and synchronized. 3. Be cautious when writing performance-critical concurrent code, and always measure the impact of optimizations. 4. When in doubt, err on the side of caution and use proper synchronization.
Those are excellent tips, Victor. Now, before we wrap up, let's reveal the answer to our quiz question. The question was, can the Java runtime or the underlying hardware change the order of memory operations in a single thread?
And the answer is yes. Both the Java runtime and the underlying hardware can reorder memory operations within a single thread, as long as the reordering doesn't affect the thread's own behavior. This is why proper synchronization is crucial in multi-threaded environments.
Wow, that's mind-bending. Now let's summarize our main points. 1. Instruction reordering is an optimization technique used by CPUs and the JVM. 2. Memory barriers enforce ordering constraints on memory operations. 3. Java implements memory barriers implicitly through constructs like volatile and synchronized. 4. Understanding these concepts is crucial for writing correct and efficient concurrent code. Next time, we'll be starting a new chapter on fork-join framework. Don't miss it.
That's right, Sheila. We've covered a lot of ground today, and I hope our listeners found it as fascinating as we do. Remember, understanding these low-level details can really level up your concurrent programming skills.
Absolutely, Victor. And to our listeners, if you enjoyed this episode, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue bringing you deep dives into Java's internals. Until next time, happy coding.